Objective physical geology, multiple choice questions with answers. These are the collection from various previous years question papers and hope these are useful for various competitive exams like CSR, NET, GATE, GSI, Civil Services, ONGC and other exams. Welcome to set 12. Coming to the first question. What is an antecedent drainage? An antecedent drainage, this was the question asked in UPSC Geologists exam 1987. The choices are A. Younger than the structure, B. Older than the structure, C. Contemporaneous with the structures, and D. Not related to the structure. So an antecedent drainage is generally older than the structure. So antecedent drainage stream, it's a stream that maintains its original course and pattern despite the changes in underlying rock topography. So the rivers which have existed before the upheaval of the Himalayas, these are known as antecedent rivers, and they cut their courses southward by building gorges in the mountains. An antecedent stream is a stream considering the changes in the underlying rock topography. It retains its original course and pattern. So it is older than the structure. So B is the correct answer. Next question. Which one of the following deposits can be considered to be the best example of wind action? A. Levees, B. Lewis and dunes, C. Moraines, D. Drumlins. So basically, Lewis and the dunes, these are the deposits which are considered to be formed by the wind action. So if you take moraines, drumlins, so these are formed due to glaciers, and levees are formed due to fluvial action. So Lewis and dunes are formed due to wind action. So B is the correct answer. Next question. What are podzoles? Podzoles are A. Lateritic soils of the tropics, B. Grey soil of the temperate, C. Red earths of the deserts, D. Black cotton soils. So podzoles are the grey soils of the temperate. So podzoles, they occur in humid areas which are in particular in boreal and temperate zones, but locally into the they also occur in the tropics also. In soil science, podzoles are the typical soils of the coniferous or boreal forests and also the typical forests of the eucalyptus forests. So here podzoles are the grey soils of the temperate regions. So B is the correct answer. Next question. Which of the following explains the expansion of the universe? Choices are A. Planetesimal hypothesis, B. Nebular hypothesis, C. Big Bang theory, D. Novio hypothesis. So Big Bang theory, it explains the expansion of the universe. The space and time were created in the Big Bang. So at the beginning of the universe, the space was completely filled with the matter, and this matter was originally very hot and dense, and then it has been expanded and cooled eventually to produce the stars and galaxies what we see in the universe today. So the Big Bang theory, it explains the expansion of the universe. C is the correct answer. Next question. Which of the following is an aseismic ridge? So the choices are A. Mid-Atlantic Ridge, B. Pacific Rise, C. Lomonosov Ridge, D. Indian Ocean Ridge. So Lomonosov Ridge is an aseismic ridge, whereas if we take Mid-Atlantic Ridge, Pacific Rise, Indian Ocean Ridge, all these are we can see the seismic activity. So what is Lomonosov Ridge? So Lomonosov Ridge, it is the ridge which divides the Arctic Ocean into two major basins, and it influences the water circulation and also marine life and ice movement too. And here the ridge crest, which is at the highest point, which is at a depth of 3,200 feet, and it rises to 6,000 to 11,000 feet from the basin floor. And aseismic ridge, this is characterized by no earthquake activity. So it is asymmetrical in shape and it has a gentle relief over its surface. And at one time it was believed this Lomonosov Ridge, it was a continuation of the mid-oceanic ridge with an associated seismic belt. And now it has been shown that though the seismic belt lies along the Nansen-Gackel Ridge, which is about 250 miles towards the Barents Seas, thus the Lomonosov Ridge is not a part of the mid-oceanic ridge system. So here aseismic ridge, Lomonosov Ridge stands as a good example of this. So C is the correct answer. Next question. Thermal remnant magnetism is acquired when a material is cooled A. Above the Curie temperature, B. Below the Curie temperature, C. At the Curie temperature, and D. Randomly. So thermal remnant magnetism is acquired when a material is cooled above the Curie temperature. So, or TRM, this is also known as a thermal remnant magnetism or magnetization. TRM is the remnants which is acquired by the rock that which contains the ferromagnetic materials or ferromagnetic substances when it is cooled from a temperature above its Curie temperature to a lower temperature in the presence of a magnetic field. Then that is known as a TRM. So, here the correct answer is A, it is above the Curie temperature. Next question. Isostatic compensation is attained at A. Moho, B. Asthenosphere, C. Stratosphere, D. Mesosphere. So the correct answer is A. Moho. Isostatic compensation is the depth of compensation is also known as a compensation level or compensation depth or level of compensation. It is the depth below which the pressure is identical across any horizontal surface. In stable regions, it lies in the deep crust, but in active regions, it may lie below the base of the lithosphere. So the isostatic compensation is attained at Moho. All these are like stratosphere, mesosphere, these are the layers of the troposphere, layers of the atmosphere. So the correct answer is A. Moho. Next question. According to the Wien-Matthews hypothesis, the polarity is reversed every A. 10 million years, B. 2 million years, C. 1 million year, D. half million year. So according to Wien-Matthews hypothesis, the polarity is reversed every 1 million years. So C is the correct. Next question. Decay of potassium 40, it gives the daughter products A. Calcium 40, argon 40, B. Potassium 39, argon 40, C. Potassium 39, argon 39, D. Calcium 40 and potassium 39. So decay of K40, it gives the daughter products like calcium 40 and argon 40. So A is the correct answer. Next question. Dating of quaternary rocks is done by during A. Potassium argon, B. Rubidium strontium, C. C12 by C14, D. U238 by Pb207. So dating of the quaternary rocks, that means which are recent rocks, this is done by C12 by C14, which has a half-life of around 5730 million years. 5730 years. So that's why dating of the quaternary rocks is done by carbon isotopes like C12 by C14. Next question. The crust at young orogenic mountain belts like Himalayas is A. As thick as the average thickness of the crust, B. Half the average thickness of the crust, C. Twice the average thickness of the crust, D. 5 times the average thickness of the crust. So the crust at young orogenic mountain belts like Himalayas is twice the average thickness of the crust. So in Himalaya Tibet region, the crust has reached about 75 to 80 kilometers thickness, which is double the normal thickness. Though high topography along mountain belts, it usually accords with the crustal and lithospheric thickening. So as a result of the plate collision, so most mountain ranges are the result of the plate collision processes of convergent plate margins. So here we can see that twice the average thickness of the crust along the young orogenic belts like Himalayas. So C is the correct answer. Next question. The volcanism found at the island arcs is A. Andesitic, B. Basaltic, C. Tholitic, D. Rhyolitic. So generally the volcanism found at the island arcs is andesitic. So volcanism in island arcs is more andesitic than in other tectonic environments on the earth, so which are mostly basaltic. So because average continental crust is broadly andesitic in composition, continental crust is either created or recycled or both by island arc magmatism. So A is the correct answer. Next question. During the Precambrian times, the rate of production of radiogenic heat was almost 7 times as at present. This was mainly attributed to A. Potassium 40, B. U238, C. Cosmic rays, D. Solar radiations. So the correct answer is potassium 40. So this was the responsible for the heat production in the Precambrian times. A is the correct answer. Next question. Cup-shaped smooth mounds in the glaciated regions are known as A. Drumlins, B. Kettles, C. Eskers, D. Cirques. So cup-shaped smooth mounds in the glaciated regions are known as drumlins. So drumlins and drumlin swamps, these are the glacial landforms composed primarily of glacial till, and these are oval shaped or cup shaped, and these are largely composed of the glacial drift formed beneath a glacier or ice sheet, and these are aligned in the direction of ice flow. So A is the correct answer. Next question. Knob and kettle topography is associated with choices are A. Glacial regions, B. Fluvial regions, C. Karst regions, D. Arid regions. Knob and kettle topography, it is associated with glacial regions. So knob and kettle is also known as a sag and swell topography. So this is the landscape sometimes formed on recent terminal moraines which are formed due to glaciers, consisting of a hummocky mound. This is known as a knob, alternating with a depression. So this is known as a kettle. So knob is known as a hummocky mound, elevated surface, whereas it is alternates with a depression, that is known as a kettle. That's why it is known as a knob and kettle, that is sag and swell topography. The kettle, it results from the melting of a block of ice enclosed in the drift. So that's why this is known as a knob and kettle topography. It is associated with glacial regions. A is the correct answer. Next question. Sir Edward Bullard made an attempt to match the continental outlines with the help of a computer at a depth of A. 500 meters, B. 1000 meters, C. 2000 meters and D. 50 meters. So the correct answer is C. 2000 meters. Sir Edward Bullard, he tried an attempt, or he made an attempt to match the continental outlines with the computer, so at a depth of 2000 meters. So C is the correct answer. Next question. Which of the following denote the inclined zones along which the continents get subducted? A. Trenches, B. Benioff zones, C. Island arcs, D. andesite line. So the correct answer is B. Benioff zones. So actually a Vedati Benioff zone, this is also known as the Benioff-Vedati zone or Benioff seismic zone. It is a planar zone of seismicity corresponding with the downgoing slab in a subduction zone. And differential motion along the zone, it produces numerous earthquakes, the foci of which may be as deep as of about 670 kilometers. And this term was named for the two seismologists, Hugo Benioff of the California Institute of Technology and Kiyo Wadati of the Japan Meteorological Agency, who independently discovered the zone. So B. Benioff zone is the correct answer. Next question. Geosynclinal sedimentation involves A. Thick sedimentary sequences of deep water, B. Thick sedimentary sequences of shallow water, C. Thin sedimentary sequences of shallow water, D. None of these. Geosynclinal sedimentation, it involves thick sedimentary sequences of deep water. A geosyncline is a large-scale depression in the Earth's crust containing very thick deposits. It is a linear trough of subsidence of the Earth's crust within which vast amounts of the sediment accumulate. That's why it's a thick, huge pile. It's a thick sedimentary sequences of deep water. Next question. According to the paleontologic and paleomagnetic evidences, the Tatrod-Pinger boundary is marked by A. Gas-Gilbert transition, B. Matiyama-Brinhes transition, C. Brinhes-Gas transition, D. Top of the Brinhes. So, according to paleontologic and paleomagnetic evidences, the Tatrod-Pinger boundary, it is marked by Matiyama and Brinhes transition. Next question. The mid-oceanic ridges reveal a pattern for A. Volcanism, B. Ocean floor spreading, C. Seismicity and D. Subduction of lithosphere. The mid-oceanic ridges, they reveal a pattern of ocean floor spreading. So a mid-oceanic ridge or MOR, it is a sea floor mountain system. It is formed by plate tectonics. So it is typically, it has a depth of about 2600 meters and rises about 2000 meters above the deepest portion of an oceanic basin. And this feature is where seafloor spreading takes place along a divergent plate boundary. Hope you have learned something, and see you in the next video. Thank you for your time.